exponential decay model. The system that exhibits exponential growth increase according to the mathematical model. Okay, so there's a typo here. The system that exhibits exponential decay according to the mathematical model, y equal y naught times e to the negative kt, where y naught represents the initial state of the system and k greater than 0 is a constant. It's called the decay constant. Example 4. Here we will use the Newton law of cooling. T of T equal T of the surrounding environment plus the difference of the initial temperature and the surrounding environment times e to the negative kt. For example, a hard-boiled egg at 98 degrees Celsius is put into a sink of 18 degree water. After 5 minutes, the egg temperature is 38 degrees Celsius. Assuming that the water has not warmed appreciably, how much longer would it take for the egg to reach 20 degrees Celsius? So the first step in this problem, we need to find a function T of T for the temperature of egg at time T. So to do that, let's first label the information that we were given. The hard-boiled egg at 98 degrees is to put into the sink of 18 degrees Celsius. This means here we are given the original temperature of the egg. This is the surrounding temperature. We are given T equal 5. And at T equal 5, the egg temperature is 58 degrees Celsius. So this is the temperature of the egg at 5 minutes. I can set up the equation so that 38 equal to the surrounding temperature plus the difference of the original temperature and the surrounding temperature times e to the negative k times t, that is 5. I can simplify this, so we get 20 equal to 80 e to the negative k times 5. So 1/4 equal e to the negative 5k. We take ln both sides, so ln of 1/4 is equal to negative 5k. Solve for k in this formula, we get k equal 0.277, and we will round it to 4 decimal place. Now that we have k, the function that used to find the temperature of the egg at time t is T of T is equal to 18 plus 80 times e to the negative 0.2773 times t. In the second part of the question, asking how much longer would it take for the egg to reach 20 degrees Celsius. Okay, how much longer? So for the egg to reach 20 degrees Celsius, we can set up our function at, okay, so 20 degrees is equal to 18 plus 80 times e to the negative 0.2773 t. So 2 equal 80 times e to the negative 0.2773 t. So 1/40 is equal to e to the negative 0.2773t. We can solve this by taking ln both sides. Divide both sides, we get t equal 13.3 minutes. Okay. So when the egg at 98 degrees Celsius, when you put into a sink of 18 degrees Celsius water, you will have to wait for 13 minutes so that the egg will reach a 20-degree temperature. Let's take a look at the next example. The spent fuel of a nuclear reactor contains plutonium-239, which have a half-life of 24,000 years. If one barrel containing 10 kilograms of plutonium-239 is sealed, how many years must it pass until only 10 grams of plutonium-239 is left? So what does it mean by saying half-life? Okay, so let's start with our formula. We know that we start out with y equal to y naught times e to the negative kt. Okay, and we know that half-life of 24,000 years would mean that in 24,000 years, there's only half of the original amount of plutonium that left. This means that I can set up the equation that's saying, okay, so one half of y naught is equal to y naught times e to the negative k and 24,000. So divide both sides by y naught. So, and take ln both sides. So ln of 1/2 equal to negative 24,000 times k. This means k is equal to ln of 1/2 divided by negative 24,000. So note that this k value here, this k formula, this is called the half-life formulas. So this is how you calculate the half-life. So given A is the half-life, then K is calculated by K equal negative ln of 1/2 divided by A, and this equivalent to say ln of 2 divided by A. Okay. So with this formula, we'll get K equal to 2.89 times 10 to the negative 5. So K is a really small number. Okay. So let's use this to calculate how many years it must pass until only 10 grams of plutonium left. If there's only 10 grams left, note that the unit is given in 10 kilograms. So if we only have 10 grams left, then 10 grams is 0.01 of a kilogram. So then 0.01 of a kilogram is equal to the 10 kilogram initially times e to the negative 2.89 times 10 to the negative 5 times t, because we need to figure out the time. So then 0.01 divided by 10 equal e to the negative 0.289 times 10 to the negative 10t, negative 5. We take ln both sides. Solve for t in this equation, we get t equal 2,390,226.74 years.